Vernier calipers. Usually a meter rod is used to measure the length of a body. Meter rod can measure the length of a body correct up to a millimeter. In physics, we need to measure the smaller objects more accurately, such as radius of a small sphere or a cylinder. For such measurements, we use vernier calipers, which can measure accurately up to 1/10 of a millimeter. Vernier calipers consists of two parts. One part is called main scale. The longer lines on this scale represent centimeters and smaller lines millimeters. The separation between two smaller lines is called pitch of the vernier calipers. On its left is a jaw A. The second part of a vernier calipers consists of a vernier scale which contains a jaw B on its left end. This jaw moves forward or backward when vernier scale is moved, whereas jaw A does not move. Vernier scale can be moved forward or backward on the main scale. The length of vernier scale is of 9 mm and it is divided into 10 equal parts. Each part is called a vernier division. The separation between two vernier lines is 0.9 mm. The difference between one main scale division and one vernier division is called vernier constant. This is the minimum length which can be measured accurately with the help of a vernier scale. That is why it is called least count of the vernier. The least count of the vernier is 1 minus 0.9 is equal 0.1 mm. Usually the least count is found by dividing the length of one division of main scale by the total number of divisions on the vernier scale. The diameter of a small object such as a small sphere is measured with the help of a vernier calipers by the following method. Number 1. Note the least count of the vernier. Number 2. Move the vernier scale so that jaws A and B join together. If zeros of main scale and vernier scale are exactly in front of each other, then number 3. Move the vernier scale towards right. Fix the sphere in between the two jaws and tight the vernier with the help of screw page. It is after 2.1 cm but before 2.2 cm. It means the diameter of sphere is slightly more than 2.1 cm. Number 4. To know the part more than 2.1 cm of the length, we look for the line of the vernier which is coinciding with a main scale division. It is the 8th division. If we multiply 8 by the least count 0.01 cm and added it to 2.1 cm, the sum comes out to be 2.18 cm, which is the correct diameter of the sphere. Number 5. If on joining the jaws A and B, the zeros of the main and vernier scale are not exactly in front of each other, then there is an error in the instrument called zero error. Number 6. If the zero of the vernier is on the right side of the zero of the main scale, then this instrument will show slightly more than the actual length. Hence, this zero error is subtracted from the observed measurement. To find the zero error, note the number of the division of the vernier which is exactly in front of any division of the main scale. Multiply this number with the least count. The resultant number is the zero error of this instrument. Number 7. If the zero of the vernier is on the left side of the zero of the main scale, this instrument will show slightly less than the actual length. Hence, the zero error is added in the observed measurement. For example, if 6 is the number of division coinciding with any main scale division, then 6 is subtracted from 10. 10 minus 6 and that number is then multiplied with the least count. Therefore, the zero error in this case will be 0.4 mm.